let's do problem number 23 on page 51. It goes like this. It says a speedboat is moving at 30 meters per second. It approaches a no-wake buoy. I don't know what a no-wake buoy is, but anyway, it's a buoy. It's 100 meters ahead. The pilot slows with a constant acceleration of negative 3.5 meters per second squared by reducing the throttle. How long does it take the boat to reach the buoy? And what is the velocity of the boat when it reaches the buoy? So let's do the given find solve thing. If you zoom out. Okay. So given. Well, here's the water. And here's a boat. Speedboat. I don't know what a speedboat looks like. It's probably pretty cool though. And speedboats always have like water like shooting out from behind them. Okay. So, and then here's the no wake buoy. And it has an eye. I guess it's always awake. And so it's 100 meters away. So this is delta x equals 100 meters. And the initial velocity of the boat is 30 meters per second. And the acceleration is negative 3.50 meters per second squared. I think that's all that's given. And when you have a kinematics problem like this, if you know 3 things in a constant acceleration kinematics problem, you can solve for everything else. So that's good. So what are we trying to find? Well, A, we want to know is how long does it take so we want to know time. And B, what is the velocity of the boat when it reaches the buoy? So we want to know the final velocity. So I've expressed what's given. I like to draw pictures so I can visualize it better. I've expressed what's given in terms of the variables I use and what I'm trying to find in terms of the variables I use. So let's solve. So for A, well, what do I not know and not need? That's the final velocity for part A. So which equation does not have final velocity in it? That would be the third one. So you'd say delta x equals v naught t plus 1/2 a t squared. Now, here's the problem with using this equation. It's not really a problem. You can do it. But if I put the values in here, you're going to end up with a quadratic, right? So delta x, this is 100 meters. This is 30 meters per second times t plus 1/2 of a. Well, what's 1/2? This will be, 1/2 of negative 3.50 meters per second squared times t squared. Now, if you plug that into a quadratic, you can get it. You can do it, and it'll work. Did anybody do that? Raise your hand if you use the quadratic. What'd you get for time?
4.53.
Oh, there should have been 2 answers.
And 12.61.
12.61 seconds. So if you use a quadratic formula, you get these 2 answers. Now, which one is right? Now, the first one is right. The first one is the one we want. What about the second one? Is it wrong? It's not negative, okay? But we'll talk about this here in a minute. What is this time? What is going on at this time with the boat and the buoy and everything else? So, but anyway, so we have an answer. T equals 4.53 seconds. Everybody agree with that one? Okay. And then part B. what is the velocity of the boat? We want final velocity. Final velocity, we know initial velocity. Now, we don't want to use time. So which one doesn't have time in it? That would be the second kinematic, or no, the fourth one, right? The fourth one? Okay, so v squared equals v naught squared plus 2a delta x. And so v is going to be equal to the square root of v naught squared plus 2 times the acceleration. The acceleration is negative 3.50 meters per second squared times delta x, which is 100 meters. Oops. So this is what, 900 minus all this stuff, and take the square root of it, and what do you get? 14.1? Everybody agree with that? Okay. Trust you. Meters per second. Now let's see, make sure this makes sense. Here we have a meters per second. It's being squared, and you take the square root of it. Yeah. And then here we've got a meter times a meter. That's a meter squared per second squared. You take the square root of that. So yeah, all the units are compatible, so we're good. And that makes sense. Now, of course, you could, if you don't want to use the quadratic formula, you could have done part B first and then plugged it into, I think, the first kinematic equation to solve for time. Let's try that. So V equals V naught plus AT. So T is equal to V minus V naught over A. So T is equal to, well, V is 14.1 meters per second minus V naught is 30 meters per second divided by negative 3.5 meters per second squared. And notice that the meters are in each term, so they cancel. The seconds on the bottom cancels, leaving 1 over seconds, so the units are compatible. So T would be, does that turn out to be 4.53? Okay. Seconds. So you could have done it this way for part A, and I'd give you full credit. Now, what about this time? What's actually happening here? Well, here, this time, this 4.53 seconds, the speedboat is slowing down, and when it reaches the buoy, it's going this fast. But if you continue accelerating at negative 3.5 meters per second squared, it's going to continue slowing down. It's going to go off the page, slow down. It's going to stop, and then it's going to speed up, and then reach the buoy again. So that's why there are two answers. There are two times where if these conditions apply, it will reach the buoy. It'll reach the buoy with the velocity of 14.1 meters per second. Then it will slow down, speed up, and then it will, what do you think the velocity will be at that second time? Yeah, it'll be negative 14.1 meters per second. And try it. Plug in this time into here, and you'll get a final velocity of negative 14.1. So it does kind of make sense. Okay. Any questions on this problem? Okay. That is all.